said number 2. Problem number 2 says identify the type of rigid motion shown in or shown as a reflection, translation, or rotation. So if you're sliding along on these ice skates, what is it? Translation. What other word would I probably accept there? Slide. Next question. Number 5. Problem number 5. Same idea there. I guess you're going from the blue to the green. I don't know, did they really say? No. It doesn't really matter.
Is it translation?
Translation again. What next, Rylan?
Number 6.
Number 6. What's that one look like it did? Reflection. What's it reflecting over?
The x-axis.
X-axis. What in the x-axis, right? Not over the x-axis, should be in. Does anybody remember what's the rule when you reflect over the x-axis? It goes from xy to
X negative y.
x negative y. You just change the sign of the y coordinate. Hint.
Can you do 13?
13.
Is that back?
Says, do we want to graph this? Do we want to take the time to graph it, or do we just want to do it?
Graph it too.
Graph it also?
Is there like an easier way?
Yeah, you just do the math. How about your notes so you can tell me the rule here in a minute? Let's see, A is 2, 0. 2, 0. That's A. B is negative 1. 1, 2, 3, 4, 5. And C is 4. 4, 3. Make sure I did that right. I'm going to erase my A there and put A down here. So that's our original triangle. All right?
Yeah.
We want to, for 13, we want to rotate it 180 degrees. Does it matter if it's clockwise or counterclockwise?
No.
For 180, if I'm standing here and I rotate 180 counterclockwise, or I rotate 180 clockwise, what happens?
It's the same.
Ends up in the same spot, so it doesn't make any difference. So what we have to do on this, and there's no other way to do it on this, we want to find A prime, B prime, and C prime. That's what our answer is going to be anyway. They didn't care about the graph. They just want the new coordinates. What's the rule for 180? Looking at your notes, what's the rule for doing 180 degrees?
X, Y, tag, negative X, negative Y.
X, Y goes to
The opposite.
negative X, negative Y. So whatever your X and your Y are in each point, you just do what to each one of them?
Make them the opposite.
Make them the opposite of what they were, or what it was. So the first one says A is 2, 0. So what's that going to become?
Negative 2, 0.
B is negative 1, 5. What's it become?
1 negative.
Negative.
1,
Yeah.
negative 5. And C is 4, 3. What's it become?
Negative 4, negative 3.
And then we could graph those if we wanted. And while you're writing them down, I'll graph them here real quick just to show you. Negative 2, 0 is right there. 1, 5, 2, 3, 4, 5. That's A prime. This is B prime. This is supposed to be a B prime. Sorry. Writing backwards isn't working too well today. Negative 4, negative 3. That's C prime. So our shape looks something like that. Does it look like we rotated that around 180 degrees?
I'd say so.
Next one, go ahead, Kelly.
I have a question about the notes actually. On the 270 degrees clockwise, what's the rule for that one again?
Somebody help us out,
'Cause I didn't get it.
what's the rule for 270 degrees clockwise?
Negative.
Like first grade math.
XY goes to what?
Negative y x.
Negative Y X.
Okay.
And Kellen, I will tell you this. If you look at that, if I'm standing here and I rotate 270 degrees clockwise, I can go backwards, clockwise should be this way. 270 degrees clockwise,
It's 90 degrees
Oh,
counter.
it'd be the same as 90. So if you got 90 degrees counterclockwise, look at it and it should be the same rule.
Yeah, it's- okay.
Go ahead.
Could you do that one with 90 degrees?
This one, just doing 90 degrees instead? Sure. Or I might come over here.
14.
What's the rule for, are we going 90 degrees clockwise or counterclockwise?
Counter.
Clock, wait, I don't know.
Pick, I don't care.
That's clockwise, I think, yeah.
You wanna do clockwise?
Yeah.
So 90 degrees clockwise. So looking at your notes, what's the rule for 90 degrees clockwise?
Y negative.
Y negative X? Does everybody agree with that?
Yeah.
Is that right? So what's that telling you you're gonna have to do to your original points? You're gonna flip them, and then do what to the second number?
Take
Change the sign, make it the opposite of whatever it was. Alright? So if our A started off 2-0, what's A prime end up? We flip them and change the sign of the second one, so what's it end up?
0, negative.
0, negative 2. It's alright if I don't write down each of the original points, you can look at your book there, right? What's B? B start off -1, 5.
5, negative 1.
5, 1.
Yeah.
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 5, negative 1.
No.
No,
5, just 5,
positive.
1.
5, positive 1, because you changed the sign of that second one, right?
Yeah.
Now, when I do this, and some of you are getting confused as you're doing it, I highly suggest, as I do it, because you're confusing me when you do it, I flip them first, then I worry about changing the sign, so I do it in 2 steps. So if my original C point is 4, 3, first thing I do is I change it to 3, 4, then I look at this, I say, oh, I need to change the sign of that second one. Then, so I do it in 2 steps, a process, that way I don't get confused.
So, if you would like, so you're making the Y be where the X should be, are you?
Right.
Are you still graphing like that? Or
Yeah.
So then you graph it this way. This is your new X, that's your new Y. That's
Okay.
your new X, that's your new
After you
Y.
flip
And
them, you just
then-
graph it like that?
Right.
Alright.
And then you said that you can find a negative for the X, will that mean like, it's just opposite, it's just. the
So
opposite
if I was gonna graph this, and we'll call this A and B and C double prime. We'll put 2 primes on it, because we already got prime over here on our graph, right?
Ooh.
So if I was gonna graph that, I come over here and I graph 0, negative 2, that's right there. That's A double prime. B is 1, negative 5, 1, 2, 3, 4, 5. No, B is, sorry, 5, I'm looking at the wrong one. B is 5, 1, that's B double prime now. And C is 3, negative 4. 3, 1, 2, 3, 4. That's gonna end up being C double prime, because we don't wanna put the same letter on here twice. Alright, well, let me do this. I wanna change the ink color so that maybe we can see it a little better. So, my A double prime is here. I connect it to the B, connect it to the C double prime, connect it to that.
Perfect.
That was a really straight line.
So now I have this. This was my original shape. Does that look like I rotated it 90 degrees clockwise?
Yeah.
what I tell you the other day, when you're gonna try to do it in your head, what's gonna happen?
It's not gonna happen.
It's not gonna work out. It doesn't work. That's why we have to do it this way, do the math, then if you wanna graph it and see it, do that. Other questions? Hurry up, Owens. Mr. Owens there had a rough night.
270. Reflected. What if you're translating it?
So if we were translating it, what would we do?
Just slide it over.
You just slide it, alright? Let's say we started with this shape, what's this translation tell us to do?
Slide
Yeah,
it
right,
over,
so-
2, 3,
Right 2,
Up 3.
up 3.
up 3. So we just take each point and go right 2, 1, 2, up, 1, 2, 3. And that means B would move to there. Right 2, up 3.
Okay.
A would move to there. Proceed, right 2, up 3, it would move to there, and it would now look something like that.
Okay.
Now, if we didn't want to graph it, and we came over here and we wanted to do A, going right 2 is doing what to the x coordinate?
Adding 2.
Adding 2, so 2 plus 2 is what?
4, 6. 4.
And then
2.
up 3,
Oh, 3.
we're gonna add 3 to that one, right? Now, what if it, instead of 2, 3, what if it said 2, negative 3? Now we go, we add 2 to all the x's and we subtract 3 from all the y's. Other questions?
Is that all the angles that we can rotate them?
We did most of them. I mean, we could went clockwise instead of counterclockwise or vice versa.
If it's 90 degrees counterclockwise, do you make y negative instead of x?
I don't know, it's in the rules in your notes.
Are we gonna get to use our notes?
Yep.
Sweet.
Matter of fact, when I put this up right here, what's it say?
Use your notes.
Use your notes. We got about, it shouldn't take you real long, it's not real difficult.
Do we need graphing paper?
Nope.
Okay.
You could just use all the rules. If you wanted to graph them, you could. I wouldn't suggest it, that's just gonna make it take longer. If you use the rules that's in your notes, you should be able to find the new points fairly quickly and easily.
Oh my god.
Getting close to the end of the 9 weeks. I would highly suggest, that if you need a binder, you grab one from over here at some point here real soon. All you're doing is the 3 things it says. You're reflecting this point. You're starting off with this point. You're reflecting it in the x-axis. Then for number 2, you're translating it to -3. Then for number 3, you're rotating it 90 degrees counterclockwise. And you're just gonna put your answers out there in the blanks. If you use the rules there in your notes, shouldn't be really all that real hard. going over this real quick. I think we're supposed to have fire drill like 9:30, so we're gonna get through this and we're gonna. Reflection over the x-axis, just reflecting over the x-axis just changes what?
This number one, the Y coordinate.
Makes the the y
Opposite.
the opposite of what it was. So what's the new coordinates gonna be?
3, 5.
3, 5. Translation, what's this translation telling us to do?
Add.
Add 2 to the x and subtract 3 from the y. So if I add 2 to the x, what do I end up with? 5. If I subtract 3 from that, what do I end up with?
-8.
So 5, -8.
I got the phone.
Yeah, I think I got the
90
last
degrees
one.
counterclockwise. Somebody tell me, I think I even said it the other day, rotations are the ones you're going to have the most trouble with. You got to know the rules and you got to use those rules. That's why I was so upset the other day when I walked around the room as we were writing them down and a few people didn't even wasn't bothering to write them down. It's sort of silly, wasn't it, Luke? I think I even said it like 3 times. You will not be able to do these unless you write down the rules.
I wasn't. Wow.
So x, y, what's for a 90 degrees counterclockwise, what's it changed to?
Y, X, Y,
Look it up in your notes.
Negative y, positive x.
Negative y, positive x, everybody agree with that?
Yeah.
So you gotta switch them around. So I'm gonna switch these first. Negative 5, 3, I just switched them. But what do we wanna do to the first one?
Make it a positive.
Make it the opposite of what it was, so it's gonna become a positive. So 5, 3.
That's right, I got
Does everybody understand?
I didn't read the problem.
I did bad on the quiz.
I read it at clockwise, not
So, yeah, you got
counterclockwise.
something right.
That's how I messed up.
Oh, I like these notes better than the ones we have on mine.
Yeah,
You
me
need to
too.
do the online ones or like.
They're
They are 2 months.
Here, I'm telling you to make sure you got the
I'm
rules
so
written down.
confused.
I don't even have them written down.
Which order does the notes go in?
Is that the wrong thing?
left to right.
The way that you picked them up.
I picked them up wrong.
It
That's
goes,
why.
there's even a number on the bottom, I think.
Yeah,
Yeah,
there
it
is.
goes
Oh,
one,
okay, thank you.
It should go 1, 3, 5, 7.
7.
1, 3, 5, 7. Thank you.
Yes. All right, thanks. Branson, they want you in the office to sign out.
You're leaving?
Branson, the assignment's on there.
Yeah.
Tell them they came and picked you up too late. You couldn't get out of it this time, but you're still gonna be due next time.
Is it quiz next time?
There's,
Or the test? I mean?
no, he's saying
When
that.
is the test?
Bro, I don't know. Probably a long time
So
away.
that's one.
I mean, quarter ends next month, next week, so. I
They'll
would
probably do it
assume
after the
soon.
quarter. Probably. Hang out the rest.
I already had it right. You have been here the last 60 days. There was a while there when you weren't doing anything you did. 3D figures. A polyhedron is a closed 3D figure. This is a polyhedron. Each polyhedron has faces, has edges, and it has vertices. Alright? Faces. Each one of these flat surfaces is a face. Alright? Each one of the corner or the edges along here is an edge. I don't know, I'm trying to think of a different name to call it other than edge.
Lines are intersection.
That's an edge. That segment on each one is an edge. Alright? I don't want to call it a corner because the corners are the points. Alright? So this is a segment, each edge is a segment, and each corner is a point. And then each face is a polygon. Right? In this case, all the shapes on here are rectangles. Doesn't have to be, it could be this one. The bottom down here, that face is a what? Pentagon, and all the rest of them are triangles. So that's a polyhedron.
3
Trigon. Not three-agon, there's no A in there.
There's a 3-agon right here.
There's no A in there, three-gon, thank you.
Okay, all prisms, pyramids.
Polyhedrons, all prisms and pyramids are polyhedrons. On this, all faces must be polygons. All the faces must be polygons. In other words, no what?
All faces must be polygons.
Circles.
No circles. No circles.
Can we write that? No circles?
No circles if you want, yeah.
No curves.
No curves in them. Not a polyhedron. Cylinders, cones, spheres. All those things aren't polyhedrons because they all have what in them?
Curves
Curves and circles.
Yes, sir. A what? Oh, want to know something? My mama got me.
Can you see that?
Huh?
I have some long arms.
Yeah, I do. I got monkey arms. Look at this.
Yo, that's wild. Your wingspan is.
Wide. I know. Long arms, big feet.
You know what they say?
So,
It's not.
you're right. What?
I
don't
the
think-
best polygon
What? I'm
ever.
kind of short. I'm pretty short. I'm like 5'8". It's pretty short.
I'm 5'8".
Yeah,
And I'm like 6
You want to hear the best polygon ever?
6 foot with you.
My mama got
No,
me.
Oh my gosh.
Watch
Oh, that's great, huh?
it. No way. That's wild.
Huh? I'm only like 5'6".
No way.
Oh,
I wish I was any taller.
Polyhedron or not?
no.
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 Polyhedron or
No.
not?
Yes. Yes.
It has
Yeah.
sides.
It's a hexagon.
It just
Two.
looks
Oh,
weird
it's
from
got
far away. You can't see
1,
it.
2,
Oh.
3.
It looked like a
Oh.
circle to me.
Looks like it's got 8.
It looked like a circle to me on the bottom.
Looks like it's got 8 faces.
Yeah. It's like a.
So this is a prism. And what we call them, what we call this, we go by each of these faces, and we're going to talk about that here in a second. We call it an octagonal prism. You name it by
The amount of.
those sides, or those faces, which we're going to call the base.
8 gone for.
Polyhedron or not?
Yeah.
Hold on a minute, don't take long yet. Gotta find my stuff here.
Oh my god. Are we going to?
You walk out the back door, you go across where the bus is parked, and stand right next to the building across the street there, quietly.
On the inside?
Sit down, shut up, and do your work, guys.
There's only one
Way to
person
be
in here.
realistic.
Oh, whoops.
We lose a whole bunch of. Fill in what you need to fill in on this slide if you haven't already. You gotta move quick now because we lost time.
Should have been slower.
I missed 4 class periods. The up here. You just.
Anna, shut that door for me.
Ugh.
Thank you.
Mr. Clark can do that good.
So the bases. Kellen, this is a cylinder. Which
Yeah.
faces are the base?
Top and the
The
bottom.
circles, alright? Now, I don't wanna say top and bottom because sometimes does a cylinder lay like this?
Yeah.
I guess, yeah.
It
We
rolls
were
like that.
recording that whole time.
It's fine.
So the bases are the two circles in this case.
Yeah.
What are the bases in this polyhedron?
The 2 octagons.
The two octagons, those are the bases. In a prism, that's what this is. This is a prism, this is a prism. All these are prisms, there's all kinds of different prisms. In a prism, the bases are the two faces that are identical to each other and they're parallel to each other.
I have a question.
Yep.
What makes the shape of prism?
If it's got like this and all the faces are
Polygons.
polygons,
Okay.
But
alright?
what about this?
Now,
Yeah, would that be a prism?
now is that a prism?
It is.
No.
But it doesn't have two faces.
It's gotta have two bases, alright? It's gotta have two bases, and that's what I'm looking for right here. So is this a prism?
No.
No, this is a
Pyramid.
pyramid. A pyramid has one base. In this case, it looks like the base is a what?
Square.
A square. One base, whatever that base is, and all the rest of the sides are triangles. Alright? Now let's go back to the prism. It's got two bases, but all the rest of the faces are what?
Square.
Not squares,
Rectangles.
rectangles.
Rectangles. Oh.
So that's what makes it a prism. It's got two bases, whatever they are, all the rest of the faces are rectangles. Pyramid, one base, and all the other faces are triangles.
The Egyptians built those.
Which one is this?
A cube.
So on a triangle, how is this not considered base? Like if it lays like that?
Because and that's what we talked about before. Does it matter if the base is on the bottom or top or side or left or right?
No.
No, so if I got this triangle standing like this, and you think that the base always has to be on the bottom, well, what's gonna be the base then?
The point.
The point? Does that make any sense?
No.
So the base, that's why we define what the base is, no matter how the shape looks, alright? So in this pyramid, the base always has to be the side that's not a, well, I shouldn't say that, because it could be a triangle, but in this case, it's the side that's not a triangle,
Oh, okay.
alright? How do you know what the bases are on this one?
Because they're parallel from each other.
They're the two that are parallel, this way. Now that's where this comes in and it gets confusing. Let's even do this one.
No,
Now,
yeah.
let's do this. This is a prism, right?
Yeah.
You name a prism again, we named this one an octagonal prism.
Rectangular prism.
This is a rectangular prism, because the base is a rectangle. Now, does that mean this is the base?
No.
It could be. Could I stand it up this way and this be the base, or? It doesn't matter on this one which one the base is, alright, because the two that are across from each other are always exactly the same. Okay? So on a rectangular prism, or cube, or this rectangular prism, it doesn't matter which one you consider the base. And that's why, where did I have the arrows pointing on this one?
On all of them.
It's not really pointing anywhere, is it? It's just saying, alright, so this could be the base, those two are the bases, could be these two ends, could be the front and the back, doesn't make any difference. Base on this, where's the base at on this cone? It's the circle, it's gotta be the circle. The other faces, if it's not a base, in this, these are my two bases where my fingers are. All these other faces are called the lateral faces. They're called the lateral faces. So in this, all these triangles are the lateral faces. Anybody know what we would call this shape? Close.
Triangular prism.
A triangular prism. The two bases are what shapes?
Triangle.
Triangles. Does everybody see how all the other faces are
Rectangles.
rectangles?
Yes.
Right? They're all rectangles. So that's why it's a triangular prism. Right? These other, the rectangles in this are the lateral faces. Anything that's not a base is a lateral face. These are just some different ones. I'm not sure what all we have to write on here. No, is there a whole lot or nothing?
Just bases.
Bases. This we call a
Squirrel.
cube.
A cube.
All right, this is a cube.
Cubitorial
What else
prism.
could you call it?
Cubitorial prism.
You could call it, all squares are what shape? All squares are
Rectangles.
rectangles, so it could be a rectangular prism, right?
Yeah.
Rectangular prism. Next one, what's that next one called?
What?
The next one up here.
A triangular prism.
The bases are what shapes?
Triangles.
Triangles, all the rest of the faces are
Square. Rectangles.
rectangles. Next one,
A hexagonal prism.
hexagonal
Prism.
prism.
Yeah.
Next one,
Pentagon.
pentagonal prism.
Square prism. What?
What's the last one?
A square prism.
Square what?
Pyramid.
Square pyramid.
Oh.
How come it's called a square
Because
pyramid?
the base is a square.
I just read that like 12 times.
The base is a square. Listen so you understand how to name these. This is a square.
Yeah.
All the rest of the faces are. All the rest-
Triangles.
Triangles.
You tricked us on that last one, didn't you?
So
What?
it's a square
Pyramid.
pyramid. When you name a pyramid, notice on this pentagonal pyramid, why is it called a pentagonal pyramid?
Because the base is a pentagon.
Because the base is a pentagon, all the rest of the faces again are triangles.
Yes, sir.
I don't know, is this even on there? It's all filled in for you. Do you know what a cylinder and a sphere looks like?
Yeah.
What's the difference between these two? Bottom and
Maybe
tip.
you just have.
The bottom.
Alright, a
is-
hemisphere is half of
Amen.
the sphere. So a
Kinda like a
hemisphere
globe.
just looks like this. What's a hemisphere have that a sphere doesn't have?
A
A
base.
base that is a
Circle.
circle.
Do, 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 do. Wow.
That's
Is
this one.
that that one?
The other one was on there.
So those, I think I got them all named for you on there, it's not a big deal, just so you can name them. Fill in what you need to fill in here. Yes, the top. We are going to deal with these, probably not these so much.
Ew, my handwriting.
All it means to be a right prism is when you stand it up here, it makes what kind of angle with the desk?
A right
A
angle.
right angle. Alright? An oblique means it would look like it's tilted a little bit. Alright? So a right would look something like this. Oblique would look like it's slanted a little bit. We won't deal a whole lot with oblique. Most everything that we deal with is going to be a right prism or a right pyramid or a right whatever.
Alright.
Oh, yeah, alright.
A regular polyhedron, before you start to write anything down, what was a regular polygon?
A polygon was a shape that thing.
What did it tell you? If I told you that this was a regular polygon, which it's
a
not,
shape.
now it might be. What's true about this if it's a regular polygon?
It's a shape.
What do you know about all the sides?
They're
Equal.
They're all equal. What do you know about all the angles?
all equal.
They're all equal. So what do you think a regular polyhedron has?
all equal sides and equal.
All equal
Faces.
faces.
And edges.
All the edges and faces are all equal to each other.
Okay.
R.I.P. paper.
You might want to write this down with this. How many faces does a tetrahedron have?
4 tetra.
It's got 4 faces. Alright? How many faces, and mine doesn't look like it, it's supposed to look like this.
6.
It's got 6 faces. How about an octahedron? It's got 8. What do you know about all those faces in each one of those?
They're equal.
They're all equal. All the faces are exactly the same. So my cube here doesn't look like it.
So
A
it's the
dodecahedron. What's that got?
12.
Yeah.
12. So all those, what shapes are those?
Pentagons.
Pentagons. It's got five sides, right? So it's got 12 pentagons that are all exactly the same to make up that shape. And then this is a, I don't know, I can't even say that word.
Icosahedron.
Here we go.
Icosahedron.
Icosahedron.
How many faces do you think it has?
20.
20.
20.
What? How do you know?
It's got 20.
There's 4 on
'Cause
top,
Jacob
4 on
just
bottom,
told us.
12 in the middle. That's 20.
So it's got 20 faces. Each of those faces is a what?
Triangle.
A triangle. Guess what's true about all those triangles?
They're all equal.
They're all exactly the same. And I'm betting Jacob knows it because if I go back here and I look hard enough, which I don't feel like doing, I probably have a die somewhere that's got 20 sides on it, and you could roll it like a
D20?
6-sided and use them for different games and stuff. Is that how you know that?
No.
Use it for Dungeons and Dragons.
Yeah, you use it for stuff like that. I
Yeah,
have
you can find
all
it.
kinds of different die in there somewhere that's got all these different setups.
Yeah, I have a bunch of
What, why, if you're rolling a die and it's this shape, how come you want them all to be the same?
So if there's the same probability,
Equal
right,
chance.
it's all-
Same probability that it's gonna come up any of the numbers, otherwise,
One has a
Wouldn't-
higher
wouldn't
chance.
work.
It's not fair.
now we're getting into the stuff that you actually have to do some math with. Surface area. what is the surface area of my triangular prism here? What am I talking about when I'm talking about surface area?
On the amount of space on the face.
Amount of space on the faces. So if I wanted to paint this, I'd have to find the surface area so I'd know how much paint to get. Alright? Surface area is the sum of the areas of all faces of a 3D shape. The units is always going to be square units or units squared, just like area for a two-dimensional shape. We're dealing with 3D shapes now instead of two-dimensional. A net is a two-dimensional drawing of a three-dimensional shape. So if I drew this, that's a net. If we folded that all up at the creases, at the seams there, what would that shape end up being?
Rectangular prism.
A rectangular prism. All right? What if I did this? Oops. That's not there.
Okay.
Triangular prism.
Be a triangular prism. Still a little harder one. What if I did this?
Cylindric prism?
It's a
Cylinder.
cylinder. It's a cylinder.
Cylinder, yeah.
Let's see. I probably can't draw anymore. That's not the limit of my drawing ability.
Oh, that's good, that's a percentage sign right there.
I think they're pretty good at drawing.
So when we're doing this, we're going to use nets to find the surface area. What I mean by that, I don't want you to use, there's formulas for everything like we said before when we were finding areas and perimeters of just two-dimensional shapes. There's formulas for all of these. We do not want to use the formulas on all of them because it's a pain in the butt. All right? What you're going to do on each one of these is you're going to find the area of this shape, area of that 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 shape, and then do what with all those areas?
Add 'em up.
Add them all up. All right?
Couldn't you
Just
find
add them
area
all up.
of one of each?
Right. If some of them are the same, then you could. And you know that these two bases always have to be the same.
And all this.
Now that-
is, right?
No, these don't have to be the same. Okay, they, on all my shapes they are. I wish I had some different ones here. On my shapes they are just because somebody was lazy and that's the way they wanted to make them.
Will they tell us if they're
Right.
the same?
They'll give you all the dimensions. So then, yeah, you'll know.
Okay.
Cylinders, cones, and spheres, anything that's got those rounded parts in them, we have to use the formulas. And we're gonna go over those formulas here in a minute. But my suggestion to you, if you're given a shape, if I'm given this shape right here, and I wanna find the surface area, how many faces does it have? So I do this, 1, 2, 3, 4, 5, 6, and Ethan O back there just told us, what do you know about, on this shape, what do you know about the front here and the back over here?
They're equal.
They have to be the same. So if I figure out the front is 25 centimeters squared, what's the back have to be?
25 centimeters squared.
So you only have to find 3 instead of all 6, right? What shape is each one of these?
Square.
Rectangles at
Rectangles.
least. And the formula for area of a rectangle is base times height. You might want to write that down somewhere. That's for a rectangle, just to make sure you remember it. What's the formula? I'm running out of space up here. What's the formula for area of a triangle?
Base times height divided by 2.
So area equals base times height divided by 2
For a triangle.
for a triangle. Those two are the two main ones when we're dealing with all these different shapes. Triangles and rectangles. Now, if this face happens to be a square, can you still find it using the rectangle formula? Yeah, it's the same thing. Remember, all squares are rectangles,
Oh, rectangles are not squares.
but all rectangles are not squares.
Can I use the restroom?
Yes.
I need to pass.
So with nets, we just talked about nets. Let's draw this on here. See how good you guys can draw. What kind of shape did I just draw? Rectangular prism. The net of that is going to look something like this. So this gets split up that way.
Just did it.
What's the date today? Is it the sixth?
The sixth.
Let me show you how to do it, Ethan. If everybody watches, I'll show you how to draw a rectangular prism. Draw a rectangle, then you draw another rectangle that sort of overlaps one of the corners. Does everybody see my two rectangles? And then you just connect the corners.
And it looks good.
And it looks three-dimensional then.
When Luke gets back, can I go?
There's another way to do it too.
Is it? Don't tell me, because I know this way, and that's the only way I want to know right now. Because it'll mess me up. Volume. When we were dealing with surface area, we're talking about if I was going to paint this shape, how much paint it would take to go on the faces, all the faces, right? If we're dealing with volume, what are we dealing with about this shape?
How much it can hold.
How much it can hold, how much will fit inside, or how much wood, in this case, it took to make this. All right?
Water tank.
If you're dealing with volume, your units, instead of square units, are cubic units. Because now what you're trying to do, I don't have anything up here, but if I had a box up here, and what we'd be doing is seeing how many of these little cubes it takes to fill up that box. That's what we're looking at, and that's why it's cubic units. Formulas for surface area and volume, fill in those. Where it says no top, we're going to write that in here in a second. So fill in for the cylinder. SA stands for surface area. And VOL, of course, stands for volume. Hopefully you know the pi symbol. R stands for radius. H stands for height.
How do you find the radius of a?
They're going to tell that to you.
Oh, they'll give it to us.
Probably. Normally, if you see a circle, the one thing that they tell you about it is its radius. Or instead of a radius, it might be the what?
Diameter.
Diameter. And you have to split it in half to find the radius. Please make sure you write it so that you can read it. I know Hannah's going to be able to, but everybody else probably going to need their notes. She's not going to need them. She's just going to have it all memorized by then, right?
That'd be a waste of memory. We can use our notes.
First thing on a sphere, on this one right here, you might want to change this, and instead of having it written this way, you might want to change it to this. 4 times pi times radius cubed, that means r times r times r, 3 times, divided by 3. That might be an easier way to put it into your calculator. Surface area. We're looking up here at surface area. Remember, for a circle, you might want to write this down somewhere, circle. The area formula was pi times radius squared. If I'm finding the surface area of this cylinder, what shapes am I finding the area of? There's two what?
Circle.
Two circles. And then the other face, this is when I drew it up here. The other face, if I cut it and laid it out flat, guess what shape it would be?
Rectangle.
A rectangle. So this face around here, if you take a pop can and you cut it apart, it'll make a rectangle and two circles.
Cut it straight.
This part is the rectangle part. So that right there is what is the rectangle. So that's this part of that cylinder. What's that mean this part has to be? The two circles. So if I had this cylinder and it didn't have a top on it, which most cylinders that we have don't, name me a cylinder out in the real world. Or something that's close to a cylinder.
The pipes underground.
Pipes,
Trash
a
can.
trash can, cup, right? All those things. What do most of them not have?
A lid.
They don't have a top on them, right? If they had a top on them, they wouldn't be real useful a lot of times. So if this cylinder doesn't have a top and we want to find the surface area, it's not going to affect the volume. Whether a cup has the top on it or not, it still holds the same amount, right? But the surface area, that is going to change it. So if there was no top here, how would we find the surface area? What's missing?
You take off one of the circles.
Take off one of the circles. So is the rectangle going to change any? So that's still 2 times pi times radius times height. Well, the area of a circle is pi times radius squared. How come we're multiplying it by 2?
Because there's two of them.
2 of them. Well, if we don't want 2 of them, what are we going to do there? Get rid of the 2 and just have pi r squared. So write that down.
Oh, I just.
So that's a formula if your cylinder doesn't have a top.
You know, at first I was completely lost.
I just had like a brain moment.
When you're looking at a cylinder, this is my cylinder. The radius goes from the center to the edge. That's your radius. This is the height. So when I lay this down, is this the height? No, the height is still from circle to circle. All right, so the height's always, no matter how this thing is, the height goes from one circle to the other circle. For a sphere, the radius goes from the very center of the ball to the edge. And that's all you need to know for a sphere is just that center out. Formulas for surface area and volume. Again, for a rectangular prism, if we're doing surface area, that's where you're going to draw it. Split off all the spaces and add them all up. So nothing hard about that. Fill that in. Volume.
Where?
Volume is the one. Is this not on there?
It is. We just didn't do code.
Nah, then it just skips pyramid.
You can always skip cone. Hopefully it's on the next slide. Hopefully I didn't delete the slide again. Otherwise we'll have to find it.
Riley, where is it?
Yeah, under cone,
It's
it's
right under
volume
cone.
equals.
The very bottom with the
Under
cone on it.
cone.
Under cone, there's nothing there. My boy, what are you looking at?
Cone, volume equals.
That's for the cone. This is for a rectangular prism.
Yeah, that probably is gonna be on the next slide.
Yeah.
So
we'll
just,
probably have to write it right here.
right, fill it in the space, there's a little space there. I'm betting that I deleted something and didn't know it. So if you're dealing with a rectangular prism, to find the surface area, you're just gonna find the area of each face and add them all up. For volume, so just fill it in right underneath here, somewhere over here, underneath there, somewhere, wherever you can find space in. My fault. We should just get rid of the write-in notes, shouldn't we?
No.
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 These are better than the online ones.
For volume, if I have this prism, which of these lengths is my base, which one's the height, and which one's the width?
Base, height, and width.
Really?
But if it's a rectangle,
You might want to do this again. Draw your little rectangular prism, mine doesn't look so hot this time. For base height and width, you pick one corner. How many segments come together at that one corner?
Three.
Three. One of them has to be your base, one of them has to be your height, and one of them has to be your width. Doesn't matter which one is which, but where they come together, there's three of them always, one of them's each of those. Remember with volume again, it's cubic units. With surface area, it's square units. Cone. Cone's a little tougher. Cones and pyramids a little harder. On this bottom one, I'm going to write this formula a different way. It might make it a little easier for you. Pi times radius squared times height divided by 3. They're exactly the same, just written in two different ways. It might be easier to put it into the calculator with that form. Either one of these two formulas work for surface area of a cone. Again, what am I looking at if I'm looking at surface area of this cone?
just the outside.
Face.
The outside, all the face area, right? So part of that face is a circle, and then you have all this stuff. So if I was gonna paint this, how much paint would it take to cover all that? That's what I'm looking at. All right? There's two different formulas, they both sort of the same thing. If my cone, if it was like an ice cream cone, would it have a circle?
No.
So if it did not have a bottom, and we wanted to find the surface area, what are we getting rid of in this formula? Remember, what was area of a circle? What was area of a circle?
Radius.
Pi times,
Radius 3.
so what are we getting rid of? That part. So it would just be pi times radius times s, or pi times radius times the square root of r squared plus h squared. And I know a bunch of you are going, gosh, those formulas are hard. Don't make them harder than they are, because you're going to know all these numbers, and you're just going to plug them in. Now, the one thing I do want you to make sure that you see on this, if I have my cone here, this is my cone. If I'm up here at the very tip top of this cone and I drop a rope down, what kind of angle is it going to form with the bottom of that cone?
90.
Alright, cause that's what gravity's gonna cause, right? This inside the cone here, that's the height. That's the height of the cone. So if I was to drill straight down through this and come out the very center down here, that would be the height of the cone. This over here on the side, if I was sitting up here at top and I slid down the side, that's the slant height. So slant height is along this, the outside.
Slant.
Slant height is along the slant, and height goes straight down through the middle. So if you are given the slant height, you might want to use this formula because it has the S in it. So if given the slant height, if you're given just the regular height, then you probably want to use this formula. Does that make sense? Because they're going to give you one or the other, maybe both, I don't know. They're going to give you one or the other. You want to make it as easy as possible on yourself. Pyramid, the other hard one. And then again, pyramid has a height. If I was to drill straight down through the middle of this and come out the center of the bottom, that's the height. The slant height is sliding down the side here. What do you think we could do with the volume? Instead of 1/3 times B times H, how could we write that?
B times H over 3.
So we could change that to that if you like that formula better. Notice, Riley, I'm not you guys. I don't just switch from big letters to small letters and stuff. If I have a big letter, it's a big letter for a reason. And in this case, big B stands for the base. Little b, remember, in a triangle or in a rectangle was just one of the edges, right? Big B stands for the area of the entire base of that three-dimensional shape.
Yes.
So you see the blue things on each one?
Yep.
That's your big B, that whole base.
The
Not
whole
just,
area.
right, the whole area, not just one of the links. So you've gotta make sure.
Then it's just telling you to find the length of that.
So if it was this one and it looks like this is a rectangle, we just do length or base times height, little b times h, find the area of that, and that's what's gonna go in here for this. So that b is the area of the base, whatever shape that base is. This one looks like
Oh.
1, 2, 3, 4, 5, 6, so that's a hexagon. So we'd be finding the area of that hexagon.
So
And again, sometimes they'll give you the slant height, sometimes they'll give you the height. If I do this, what kind of triangle did I just draw there?
Right
A
triangle.
right triangle. And that's what we're gonna learn next, and some of you already know this, so it's not real difficult. You have a right triangle, how can you find one of the missing parts if you don't know it?
Pythagorean theorem.
Pythagorean theorem. That's what's next, Pythagorean's theorem, a squared plus b squared equals c squared. A squared plus b squared equals c squared. So if you're in that triangle, your c here would be the slant, or in that pyramid, your c would be the slant height, and this over here would be the regular height, and this would be going from the center across the bottom, sort of like half the length of the base. And it'll probably tell you that. But you should be able to find one or the other. Remember, the hypotenuse always has to be across from the right angle. These other two sides are called the legs, the A and the B are called the legs. The assignment,
Diagonal, we have the examples with it.
1 through 15, 8.
the assignment's on page 113.
Do these take,
So if, with Pythagorean theorem here, and you've seen it before, you can use it to find, if we're looking at a, whether it's a cone or a, some kind of triangular, or not triangular, some kind of pyramid, alright? If we need to find the slant height or just the regular height, and either one of these, slant height, oops, sorry, that's not slant height. Slant height comes down this side, the middle of one of the sides. Or the regular height that comes down into the middle here, forms a right angle. So if we go back to these other formulas and look at these formulas, like this formula, we need to find this slant height because you like this formula to find the surface area better than this longer formula. You can find the slant height using Pythagorean theorem. And that's what we're going to do. I'll show you a couple of examples here. So remember, Pythagorean theorem is always a squared plus b squared equals c squared. That c is always across from the right angle. That's always the hypotenuse. The other two sides are called the legs. With the legs, it doesn't matter which one's which leg. There's just two legs. The one that matters is the c. That's always got to be across from the right angle, and it's the hypotenuse. So on this, if we're looking at this pyramid on this first one here, we'll call this number one. We're looking at this pyramid, and we want to find the slant height or the height. Well, the height here is this. That's 6. So we know the height is 6 inches on that one. So if we wanted to find the slant height, which is coming directly down one of the sides, like you were sliding down one of the sides. Well, we can form this, and that's always going to be a right triangle. And that right triangle, if I draw that right triangle off over here, this is always 6, or this is the height, that's 6 inches. And we're looking for this, the slant height, so that's what we don't know. Well, this bottom side, if we look right here, it's going to actually be half, this length is going to be half as long as one of the sides, or that side of the pyramid. So since this is 10, this has to be 5. And then to find that slant height, all we have to do, slant height's going to be here, that's actually the c in Pythagorean theorem, is we just do 6 squared plus 5 squared equals c squared. And if you grab your calculator, you can punch all of this side into it, or since I don't have a calculator, I'll just do it. 6 squared is 36, 5 squared is 25, that equals c squared. Add those together and you end up with 61 equals c squared. Then what we have to do is take the square root. And that's going to tell us this slant height. So if I grab a calculator and I find the square root of 61, square root 61, I end up with and not that. Second, square root 61, end up with about 7.8. So the slant height here, ignore that, the slant height is going to equal about 7.8 inches. And then we could use that slant height in one of the formulas if that's what we want to do. Now, if we're looking at this and we don't want the slant height, we're given the slant height, but we want to use the formula that deals with the regular height, we still have a right triangle here. And in that right triangle, again, this is one of your legs, that's a leg, that's a leg. This side across from the right angle is the hypotenuse. And we can just set it up, we don't know one of the legs, so that's A, we'll just say that's A squared, plus the other leg is 5, so 5 squared, and it equals this, the slant height here, which is our hypotenuse, 12 squared. Well, when we go to do that, you just do the little math, A squared plus 5 squared is 25, 12 squared is 144, then you just solve it like you would a normal equation. Ignore that. You end up with A squared on this side, the 25s cancel out. Grab your calculator, 144 minus 25, that gives us 119. And then we take the square root of both sides. That's going to leave us with A, and whatever the square root of 119 is. Looks like it's about 10.9. So on this one, they told us the slant height, it was 12 centimeters. We didn't know the regular height. And it ended up being, when we used Pythagorean's theorem, it ended up being about 10.9 centimeters. And once we find either one of those, the slant height or the regular height, then we can go back to one of these formulas, whichever formula we need. Here, for this formula, we need just the regular height, which is one right down the middle here. And for these other ones, you could either use the slant height, which is the S, or the regular height, which is the H. And you just decide which formula you want to use it. All right, on this first example, they ask you, is this a polyhedron? So is this shape a polyhedron? And the answer there is yes. On this, they want you to find a base, the faces, or tell how many bases it has, tell how many faces it has, tell how many vertices, forgot my hole in there, how many vertices it has. So if we look at this, with this one, as far as a base goes, it's just going to have the one base. It'd be hard to figure out which one is which because this looks like one where they're all the same, so it wouldn't really matter. Faces, if we look at this, looks like it's got 8 faces. The edges, each one of these is an edge, so we could just count them. There's 4 there, another 4 there, that's 8, and then there's 4 down here along the bottom, so it's got 12 edges. And then the vertices are just the corners. 1, 2, 3, 4, 5, and 6. It's got 6 vertices. The other one, is this a polyhedron? And the answer is no, because it's got circles in it. So it's not a polyhedron. If we want to do the bases and the faces for it, it's got 2 bases. The circles are the 2 bases. And as far as faces go, it has sort of 3, and that's sort of questionable, but you got your 2 circles, And then, remember this, if we cut this open and lay it out flat, it'd actually be a rectangle. Edges, well, it doesn't really, since it's not a polyhedron, it doesn't really have the edges or the vertices the same as a polyhedron, and it doesn't really have the faces the same either, but we could sort of get some idea. But it does have the two bases. This one, how many bases does this have? Remember, on this is a triangular prism. With any prism, you got two sides that are the bases, and all the other sides have to be rectangles. Well, the bases have to be the same, exactly the same, congruent to each other, and parallel. Well, the bases this time are these two triangles. So it's got two bases, which are the triangles. So if I wanted to name them, I could name them triangle HIJ, and the other base is triangle MLK. Then all the other bases are rectangles. So it's got three other faces, and we could name those rectangles if we wanted. I'm not going to name all of them. The edges, you just count up how many edges it's got. 1, 2, 3. I counted those three. 1, 2, 3. So that's 6 total. Then you got 7, 8, 9. It's got 9 edges. And then the vertices is just the corners. 1, 2, 3. 1, 2, 3. So it's got 6 vertices. Identify the three-dimensional figure that can be modeled, or that can model the beverage container. State whether the model is a polyhedron. So they're just asking, what three-dimensional figure does this, or would best represent this container here? And it would probably be a cylinder. And they ask, is it a polyhedron? It's not a polyhedron, because it's got circles in it. It's not a polyhedron, nor all those stray marks. Find the surface area and the volume of the rectangular prism. Anytime you're looking at something like this, pick a corner, pick a vertice. A rectangular prism is going to have a length, a width, and a height. Well, there's always 3 segments that go into every corner, every vertex, and those 3 are your length, your width, and your height, and it doesn't really matter which order they go in. It doesn't matter which one's the length, which one's width, which one's the height. So if I'm picking this, I know that this side is 5.2 centimeters. This edge is 10 centimeters. This one, it's not labeled, but when we look at a rectangular prism, if this is 6 centimeters, then that means that has to be 6 centimeters. So now I'm going to find the volume first, because volume's very easy. Volume, we just use the formula. Length, base, volume equals base, and that's little b, not big B, times height, times width. It doesn't matter which is which. We'll say the base is 10, we'll say the height is 6, and we'll say the width is 5.2. You grab your calculator, and you multiply those together. So I grab my calculator, and I multiply them, and I get 312. And our units, since we're dealing with volume, that's how much will fit inside that shape. It's going to be centimeters cubed. So that's our volume. Now for surface area. Surface area is a little different. There is a formula for surface area, but it's easier in the real world to just find each face, each one of these rectangles is a face, find the area of each face and add them all up. So if I'm looking at this rectangular prism, I know it has 6 faces. Has a top, looks something about like that. Well, the top and the bottom are the same, so I'm just gonna draw those two together. Then it has a front face here. Looks something like this. And the back is the exact same as the front. And then it has the 2 ends. So I'm gonna separate those off. And both the ends are exactly the same. Now all you wanna do, each one of these is a rectangle. So for the area of a rectangle, it's just, I keep doing that. Area of a rectangle is just base times height. So we just want the base and the height of each one. If I'm looking at the top, let's look at the bottom because it's the same. Well, the 2 dimensions that go with the bottom, 10 and 5.2. So to find the area of these, I'm just gonna take 10 times 5.2. Grab your calculator, that ends up being 52. So the area of the top is 52, area of the bottom is 52. Then for the front face, notice it's got the 6 and the 10. So we're just gonna take 6 times 10. Well, that's 60. That's for the front. Well, then the back's gotta be 60. And then the ends, the 2 dimensions that go with the ends for the length and the width are 6 times 5.2. Grab your calculator and you do 6 times 5.2 and you get 31.2. So the area of both ends is 31.2. And then all you're gonna do to find the total surface area is add all of those up. So 52 plus 52 plus 60 plus 60 plus 31.2 plus 31.2, and I end up with 286.4. And our units this time, because we're looking at surface area, so what you're actually doing when you're looking at surface area is you're saying if you had little like post-it notes and you were gonna cover this with all the post-it notes, how many of those little post-it notes would it take? That's what you're looking at. If we were gonna cover it with post-it notes, or if we were gonna paint it. So it's just centimeters squared. It's just like any other area. Find the surface area and the volume for the cone. Round your answer, round each measure to the nearest tenth if necessary. All right, for a cone, doesn't really matter which one we do first. You have to look back at your notes and find those formulas. We'll do surface area first. If you look back in your notes at the formula, surface area, one of them is pi times radius squared plus pi times radius times slant height. And then the other one is pi times radius squared plus pi times radius times the square root of radius squared plus the height squared. You can use either one that you want, right? On this one, we know the height. This is the height, that's the h. This is the radius, so that's the r. We don't know the slant height, but we could find it if we wanted to use Pythagorean theorem. So it makes no difference if you want to find that slant height. All you would do to find the slant height, and we can do it either way. If we want to find the slant height, that's got to be the hypotenuse, so it would be 8 squared plus 15 squared equals c squared. And we just do this math. You can punch all that right there into your calculator and get that side. So 8 squared plus 15 squared and hit equals, and I get 289 equals c squared. Then you take the square root of both sides, and when you take the square root of it, you get that this slant height is 17 inches. So now we could use, and again, I'm gonna write these two formulas down. One of the formulas is pi times radius squared plus pi times radius times slant height. We could use that one, or we could use pi times radius squared plus pi times radius times radius squared plus height squared. We can use either one of those, alright? This one's, the top one up here is probably a little easier if you know the slant height. If you didn't know the slant height, and you didn't know how to use Pythagorean theorem to find it, then you could use this one. Don't make these formulas harder than they are. All you're doing is plugging in numbers, and then you can plug it all right into your calculator. So if I wanted to do, let's do this bottom one, because we didn't know the slant height at first. All I'm gonna do is put in pi, I'm gonna hit the pi button on my calculator. Then the radius this time is 15, so 15 squared. So pi times 15 squared plus pi times 15, then square root 15 squared plus the height was 8, so 8 squared. You're just plugging in all those numbers. Now, if you wanted to plug all of this into your calculator just like it is, the only thing that you got to remember to do is you're gonna have to put parentheses around that stuff underneath the square root. So if I type this all into my calculator, I'm gonna hit the pi button times 15 squared plus, hit the pi button again, times 15 times, then the square root. My calculator puts this first parenthesis in there, so all I have to do is close the second one. So then I put in 15 squared plus 8 squared, then close the parenthesis and hit equals, and it tells me that my answer is 1507, and then I look back up here and it says round it to nearest tenth, so I want to go out 1 decimal place, which is actually going to make this an 8 and make that a 0, because it's 9/6, and when I round the 9 up, it's going to make this an 8 and make this a 0. And since we're dealing with surface area, it's inches squared. So I just typed it all right into my calculator. This top formula, let's hope it comes out the same or I'm gonna look awful silly. So pi times 15 squared plus pi times 15 times, we found the slant height to be 17, so I'm just gonna stick that in there. Now in your calculator, you're just gonna type all that in. So I hit the pi button times 15 squared plus pi times 15 times 17, and I hit equals, and I get 1507, and then we want to round it off to the nearest tenth. Again, I got a 6 that tells me to round the 9 up, so it's going to round up to 1508.0, and our units are inches squared. So either way, we got the same answer. Whichever formula, either this formula or this formula, whichever one you use, you're just writing it down and putting the numbers in there. Alright, don't make it harder than it is. The formulas look hard, but you know all the numbers and you're just plugging them in and then using your calculator. If we want to find the volume, the formula for volume is pi times radius squared times the height, and it's got a 1/3 on it, but we said you could change it to divided by 3, and that might make it easier. So on this, it's just going to be pi times the radius we know is 15, so 15 squared, times the height, that's the regular height here, which they told us is 8, and then divided by 3. I'm going to do all of the top first, and then hit equals, then just hit divided by 3. So I grab my calculator, and I do second pi 15 squared times, oops, I messed up, so pi times 15 squared times 8, hit equals, and then hit divided by 3, and I get 1, 8, 8, and again, I look at the tens place, it's a 9, and the number right behind that 9 is a 5, that tells me I rounded up, so I'm actually gonna have to round this 4 up to a 5, and 0 there. 9 becomes a 0. And that's inches, since it's volume, that's inches cubed. So what we're doing when we're finding volume is we're seeing how many of these little cubes does it take to fill up that whole cone. New Year's Eve, each year, millions of people watch the descent of the New Year's Eve ball in New York City. The New Year's Eve ball is a geodesic sphere that is 12 feet in diameter. It weighs 11,875 pounds. Is lit by 3,256 LED lights and is covered with 2,688 crystal triangles. How many lights are contained on the ball's surface within an area of 4 square feet? So 4 square feet. So the first thing we're going to have to do is we need to find the ball's surface area. The formula for surface area, if you look back in your notes, we'll consider this a sphere. If you look back in your notes, the formula for surface area of a sphere is pi, or I'm sorry, that's wrong. It's 4 times pi times radius squared. So all we do is plug in radius this time. You gotta be careful here. It says 12-foot diameter. That means the diameter all the way across the ball. But we don't want all the way across. We want from the center to the edge. So we only want half of that. So it'd be 6 squared. We type all that into our calculator, and we're going to round it off to the nearest tenth, just like we've been doing everything else. So when I type it in my calculator, 4 times pi times 6 squared, and I end up with 452.4 feet squared. So that's the total surface area of the ball. Well, we don't want the total surface area of the ball. They want to know how many lights there are in 4 square feet. Well, we don't have 4 square feet. We have 452.4 square feet. But what we can do is, if the total surface area is that much, and we know that there's 3,256 lights on the whole ball, we can take that 3,200 or 32,256 and divide it by this number, 452.4. This is feet squared, and this is lights. And what that's going to tell us when we do that division, it's going to tell us how many lights there are in each square foot. So if we just take out one little square foot here, how many lights fall in that little square foot area? So we divide that, and I come up with, and we're going to round it off quite a bit, about 71 lights per foot squared, or square foot. Well, that's still not the answer we want. They want to know, this is for 1 square foot, they want to know how many there is in 4 square feet. Well, all we got to do to find that then is take 4 times 71, and we get 284 lights. So about 284 lights in a 4 square foot area. So if we took a 4 square foot area here, there'd be about 284 lights in that little part. New Year's Eve, each year millions of people watch the descent of the ball, so on, so on, so on. It all says exactly the same thing, except for the bottom part here. It says, Tony is repairing a section of the ball that is 8 cubic feet. So now that we're dealing with cubic feet, we're no longer dealing with surface area. We're dealing with the volume of the ball. How much does the section weigh? So if we're dealing with volume, we look back in our notes, the formula for volume of a sphere, and I said you could write it this way, it might make it a little easier. 4 times pi times radius cubed divided by 3. So if we plug in here, it's 4 times pi times the radius. Well, the radius again, they tell us the diameter, but we want the radius. Radius is 6, so we take half of that, 12. And then it's to the 3rd power divided by 3. I'm going to change this because I don't like using to the 3rd power. Squared is pretty easy because you can find the squared button on your calculator. To the 3rd power just means you take that number times itself 3 times. So 4 times pi times 6 times 6 times 6, and then divide that by 3. If I grab my calculator and I do all that, 4 times pi times 6 times 6 times 6, I'm going to hit equals then, and then I'm going to hit divided by 3, and I end up with 904.8, let's say. That's the volume of this whole sphere. And so what would that would be in feet cubed. So cubic feet, 904.8 cubic feet. Then what they want is they want to know how much does 8 cubic feet weigh. Well, again, they didn't tell us anything about 8 up there, but they did tell us the weight of the entire ball was this. So what I'm going to do now is I'm going to take that 11,875 and I'm going to divide it by the total volume, which is 904.8. So grab your calculator, 11,875 divided by 904.8, and I end up with 13.1. What that's telling me is that each cubic foot, so each foot cubed weighs about 13.1 pounds. Well, they didn't ask us about each cubic foot. They want to know about 8 cubic feet. So all we're going to do is take that 13.1 and times it by 8. So 13.1 times 8, and that gives me about 104.8. And our answer is in pounds. So an 8 cubic foot section is going to weigh about 104.8 pounds. All right, that's the assignment. Page 113, 1 through 15, and 18 through 20. About 18 problems.